Hello, hello, ladies and gentlemen, welcome back. In this video, we are going to add functionality to our box collision blueprint so that we can change the size, location, and scale of the box collision so that it can be custom shaped without affecting anything else that may exist within that particular blueprint. After that, we're going to talk a little bit about debugging our code, teaching you to solve your own problems before you need to ask for help. Additionally, I want to go further into creating functions and macros and how they can help reduce nodes within your code. Lastly, I want to go over the level blueprint and how it differs from other more standard blueprints. So let's get going. The first thing we want to do is open our trigger volume blueprint, make sure we are in the construction script, drag our box collision reference into our blueprint. From here, we want to set relative transform. Then we want to take our construction script input and hook the execution pin into our set relative transform. Then we want to go to our new transform pin, drag a line out from there, let go, and select make transform. Remember, we are reading our blueprints from left to right, so we are in effect currently working backwards. Next, we just want to go ahead and make variables for our location, rotation, and scale. Lastly, we just need to go ahead and make our variables public so that when we compile and we select our blueprint within our level, we have location, rotation, and scale within our default group. And that means we can essentially just, in real time again, stretch these out. We can make rotation and location modifications. So it's much easier to trigger our blueprints from a much larger area. The next thing I want to talk about is debugging. Now, nobody's perfect, and no code is necessarily going to be perfect the first time. One of the things I kept doing to myself when I was recording the previous video is that I would occasionally forget to set my default value for my player tag variable, and my blueprint just wasn't working. Now, because I've been using blueprints for years, I was very quickly able to identify the problem. However, for those of you who are not that experienced, or perhaps your blueprints are just that much more complicated that you can't keep the whole thing in your head, here are a couple tricks for debugging your code and figuring out where the problem lies. So let's go ahead and break our code intentionally by deleting our default value. We're going to hit compile, and then to confirm that nothing's working, we're going to go ahead and re-enter our volume, and of course, nothing happens. Now, one of the very helpful things that exists within Blueprint is that when you're simulating, you can actually see your code executing. Now, you may have noticed this happening in previous videos, but I never really talked about it directly. So let's go ahead and keep an eye on our onComponentBegin overlap chain within our blueprint while I'm simulating. As you can see, there was an orange outline over our window with a big piece of text that says simulating. And when I walk onto the box, you can see it trigger. However, it's not getting past our branch. This tells us that our code is failing. Now, there are no errors detected, and this can be kind of confusing because if there's no errors, then technically everything's working the way it should. But obviously, our code isn't functioning, and what that means is that once it gets to the branch, a false condition is being indicated. To understand what that is, drag a pin out from the false output of your branch, let go, and type in print string. So now that we have our print string, we can go ahead and simulate again. And if you watch our blueprint again, you can see everything will fire through and go exit through the print string. And of course, this text hello is going to appear in the top left-hand corner of our viewport. Now that we confirm that our branch is recording a false condition, we're going to need to dive further and figure out why that is. So let's go back to the node right before it. this is what's generating either our true or false conditions. So let's go ahead and drag a pin from this output into our end string as part of our print string. Unreal Engine automatically creates a conversion node to convert our condition to a string. Again, a string within blueprints, or basically any code, is just a line of text. Compile, hit play, and now the text at the top of the screen says false. Now, at this point, we have two possibilities of where our problem is coming from. It's either we're getting the wrong indication from our array, or our player variable has the wrong information. Now, of course, because this blueprint is so simple, all we have to do is check this to determine whether or not this has a problem. Now, imagine our blueprint's a lot more complicated and our options are not as clear. So as opposed to dragging our output pin into our string from here, let's take it from our get node, plug it into here, delete what we don't need anymore, and see what results we're getting. We enter our box, we can see that we are getting the correct result that we put in the previous video, which is our character has a tag that says player, and that's what we're looking for. So we know we're getting the correct result from our character. And if we take the pin from our variable, plug it in there, delete what we don't need, hit compile, and enter the box again, we're getting the result none, which means we didn't put anything into our variable. So now we know what the problem is, and we can correct it. Hit compile again, run through, and now everything's working again. Now again, this is a very simple blueprint, and ultimately this wouldn't be necessary in something so simple if you really understood what was going on. Now in a much more complicated situation, using print strings is a really good way to debug blueprints, but it's also a good way to simulate functionality that hasn't been built yet. So for example, we go ahead and delete that and say we want something to happen when this fails. We could theoretically just put in, whatever string we wanted in here to say, and then X happens. All right, so say there was a puzzle for disabling the security system. You could have that as part of your condition, and if the security system is disabled, you'd have a branch with an output, and if that condition was successful, you could have a string that said success, showing that your security system did not enable. So after that, you could then theoretically have a door open or something like that your character could walk through and progress through the game. Because blueprints take time to assemble, theoretically use strings to indicate something that could happen next, or just show you what's happening within your own blueprint while you're simulating, to show that specific milestones were being met as your code was executing. I use print strings a lot, and I'm really not sure what I'd do without them. Next, let's talk about organizing our blueprints a little bit better. Now, I mentioned functions and macros in the previous video, and showed you where to create them, but I didn't really show you what happens when you do. So let's go ahead and do that. This code here is being replicated throughout our entire blueprint. Now, if this was a more complicated piece of code, you might go, I need to create this as a macro or a function so that I can replicate that code throughout my blueprint, and anytime I want to change that code, I just go into the function or macro, update it, and then that function or macro will update throughout your code. To do that, select the code that you want to replicate, right-click on it, and in this case, we're going to call it a function. We're going to click, and we get this. Now, a function has to have execution pins moving through it, or else it's not going to work. It's just like get all actors of class. Anything with this little F in front of it is a function. Now, in this case, we don't need an execution pin because we're essentially just doing some math. We're doing some operations that are just doing some checks and whatever, and we don't necessarily need it to be executed. So let's undo that, select all our nodes again, and select macro. Now, our macro does not need an execution for it to get it to work, and so in this particular case, it's going to be ideal for us. So let's go ahead and double click on our macro, we now see our original nodes, and we have inputs and outputs associated with that as well. Now, if we select our input and we go over to our details panel, we have the ability to not only name but reorganize our inputs. We can also create more inputs and outputs at the same time. So let's go ahead and do that. So for our object reference, self is a reference to to something's own self, and it's not correctly named here. In the case of our event graph, we're actually getting our other actor in here. However, other actor is only true when we're talking about overlapping. If we go over here, we're referencing an array element. So calling it other actor or array element in both cases is not necessarily accurate. So let's go ahead and jump back in here, select our input, and we'll just call this actor. Because at any point, anytime we use this, this is going to be a reference to an actor. Hence the blue actor object reference input pin. Here, and with our pink input pin, it's just labeled B because Unreal Engine really didn't know what to call it either. We can, however, in all our use cases, confirm that we are referencing tags here. So we can call it something like tag to compare. Hit compile, go back to our event graph, and you can see our input names have changed. Go back into our macro, and we have our Boolean variable. Now, a return value for that is probably fine. I don't really see a reason to worry about that. However, what if we have multiple elements in our array and we want to make a determination? Hey, in this case, we want to use, instead of array slot 0, we want to use array slot 1. We can go ahead and drag this pin into our input, let go, and it automatically creates an input for us. Unfortunately, it gives us a weird name called dimension 1. That doesn't really help us at all, so we could just call this array element. Hit compile. Now, if you're like me, the fact that these lines cross is annoying at best. However, these up and down arrows here allows us to change their order. And so now that I've clicked the up button on the integer, it's moved it up a level, and we can hit compile. We can go back to our event graph, and now we have our array element 0 here. We could theoretically plug in a variable here that we can change, or we can just leave it as is, because we don't really need it to be anything else than what it is in this case. But this does give us access to that without having to go into the macro. Now, because we have our macro here, we can go in and we can delete this code here, drag our macro in, grab our other actor pin, grab our tag to compare, plug that in, and then plug a return value here. And then we can do the same thing here, where we drag our macro in, delete the nodes that we don't need, plug our actor in here, our tag to compare here, and plug our return values into our conditions. And that's it. Now, anytime we want to, again, add functionality here, we could add a pin. It doesn't have to do anything in this case, but when we compile, go back to our event graph, we'll see that that pin has been added to all of our macros. Go ahead here, let's get rid of it. We compile, go back to our event graph, and it's gone. So now we've established that we can create little code nuggets that we can replicate throughout our project. You, of course, can rename your macro by right-clicking on it and renaming it, and call it tag compare. And of course, now all our macros have been updated with the new name. Additionally, once your blueprints start getting really complicated, you're going to want to better organize them and label what each kind of section does. So what I'm going to do here is I'm going to select all my nodes in the begin overlap phase, and then I'm going to hit C on my keyboard. As you can see here, just like we did in the material editor, I've added a comment. And we can name that comment begin overlap. And if we want to get extra cute, we can color code it. Hit OK. Select our other group of nodes. Hit C again, and we're going to call this end overlap. And we can tidy this up. And then give it a slightly different color. Typically what I do is I'll do like color variations that are similar so that you know they're somewhat related. Again, say you have a very complicated blueprint and you want to dial down and make it easier to tell each kind of subcomponent apart from the next. You could theoretically then have all these under another comment, and we're just going to call this overlap. And that will tell us that everything within this bubble here is overlap. Now, again, you can make this a different color. And if you're like me, you're going to color code it somewhat. However, having all these kind of colors on top of each other is a little weird. So what I tend to do is make my subgroups just black or very dark with a different shade to somewhat distinguish them from each other just a little bit within the same group. But once you have a comment, as I just kind of showed you, you can move the whole thing around and help organize the layout of all your blueprints in such a way that it's very easy for you and other people to read. Lastly, I just wanted to talk a little bit about the level blueprint. I kind of have a love-hate relationship with the level blueprint. The level blueprint is something that can be very useful. It is, however, tied just to the level and only affects things that are in that particular level. It can communicate with other blueprints, but it is essentially a non-asset blueprint. If you go to your blueprints button at the top of your screen, and I'm sure many of you have already found it, a lot of people I've talked to over the years, especially when collaborating on something, have automatically jumped to the level blueprint and started doing their code there. And that kind of gets up my skin a little bit because that is not how I do things at all. I suggest to people that they use the level blueprint as little as they humanly possibly can. So let's go ahead and open it. Go down to level blueprints, open level blueprint. And just like every other blueprint, it's just an event graph. It has no viewport, it has no construction script because it is its own entity. Now, the main thing that separates level blueprints from your other blueprints is that you can literally drag things from your world outliner into your level blueprint and affect them directly. If you recall, in our trigger volume, we actually had to do searches for elements that existed within the level at runtime in order to find them. And if we had a lot of them, again, I talked about how hard it was to establish them in a specific order. You can literally grab all your rotor lights, drag references into your level blueprint, and turn them into an array. And so in this scenario, you wouldn't necessarily have to do a get all actors of class or get actors with tag or even do gameplay tags in order to do this. However, this functionality is locked to this level. And so anytime you go to a new level, you can't carry this with you unless you replicate everything. You can copy and paste the nodes, but the references will be broken unless all those assets exists. So, for example, a duplicate of your level could theoretically be made, and this might carry over and not break. Likely, it's still going to break for any number of reasons. Something like maybe the internal object count or object number reference that it gives every actor in your scene might be different and could theoretically break this. I'm just hypothesizing. I haven't really researched that particular use case, but again, this code will only stay with your level, and you can't migrate it to other things. So ideally, what you want to do is set up your blueprints so that you can migrate. So if you right-click on an asset in your content browser, go to Asset Actions, you can migrate this asset and anything it references to another project that has nothing to do with this project, and it'll just copy just the references that it has. So it'll pull in my rotor light or anything else that it needs to reference into the content browser of another project. If we go ahead and click on it, it'll actually tell you what it's going to grab, and it will grab my rotor lights as it shows here. So that's one way of using a level blueprint. Sometimes I'll use a level blueprint just to handle prototype stuff without having to go in and create a lot of assets. But again, I would suggest only at best using it to prototype stuff and just leave the bare minimum in the level. Usually I use it for level start conditions, like doing graphic settings and determining screen resolution or whether or not I'm full screen or in windowed mode. Any blueprint can execute a console command, but typically these are things I leave for the level blueprint. I'll also use the level blueprint to do things like play sequencers. You can, just like in any other blueprint, do an event begin play and start executing code when your level starts. And that's generally what I use it for. And that's going to wrap up this video, and with it, our introduction to blueprints as part of our Lightwave 2 Unreal Engine series. I could go in multiple different directions at this point and kind of dial in deeper into various features. However, I would like to hear from you, the Lightwave community, what you really want to see. Just remember, I'm not an expert at everything, so things like character-related stuff I am less skilled at than general game logic, and especially lighting and cinematics. So again, I want to thank you all for watching. If you like this video, please hit the like button on YouTube, subscribe to my channel, and hit the bell notification icon if you want to get notified every time I upload a new video. Again, thank you for watching, and I'll see you next time. Bye.